Assalamualaikum. My name is Mohamad Zulhairi bin Mohamad Noor, and my supervisor is Dr. Rizal Effendi bin Mohamad Nasir. I'm thanks to him because helped me done my proposal. There is a structuring, landing gear, and integrated system designed for unmanned aerial vehicle. In this paper, we'll interpret the 3D print fixed-wing UAV project in the Flight Technology Test Center, purposely for surveillance that had been designed with some specification and parameters that required a lot of improvement for commercialization. In this scope, we'll cover the static analysis by using finite element method for the UAV in order to determine the best structure and improve the printed technology traditional idea for landing gear. For the integrated system, it is desired to reconstruct the space and arrangement of system to have a high value product. For integrated system, we'll cover will improve the previous structure of integrated system with proper arrangement of apparatus for charging supplies in current mid-fuselage design. With proper arrangement, it will consider the temperature that will generate by the system, which is could affect the structure of mid-fuselage made from polyclatic acid. That is in the short form called as PLA for 3D printing. You can see here the current design for UAV. I will explain one by one the compartment of the fuselage. Okay, this is the rear fuselage, this is the front fuselage, and this is mid fuselage. So at the mid fuselage, I will place the integrated system design at the top and the charging and battery supply at the bottom. Okay, this is the landing gear, the rear landing gear, and this is the front landing gear. The problem with the landing gear is this is permanently attachable at the rear fuselage. So our design is with detachable landing gear and addition with some mechanical system that could detachable from the rear fuselage. And that is a suspension system. Without the suspension system, such like spring or damper, the landing gear UAV are in solid rigid model that can cause high stress and strain leads to occur some defect on the printed part, either on the fuselage or landing gear. For the arrangement of the integrated system will based on the mid fuselage. The components such like ESC, GPS, CPU, telemetry, and Wi-Fi will be designed connected each other in one component to optimize with the current design of UAV. Means that it will consider the parameters of the mid fuselage to place at the top. Imagine the system that I will design will be like a power bank. So with this design, the connector will be at the side of the compartment. For literature review, early 2020 from Plavita Sonowal, Somidas Dargesh Kumar Mishra. Simple design of landing gear analysis was conducted to find the relation velocity of impact and force acting. The result obtained that increasing velocity of impact will increase the force acting on the landing gear. They got that the data 3.7 to 2.1 safety of factor without any failure detection during FAA. Means that are the best range they got from the increment of velocity of impact. What they required is to determine the maximum speed the landing gear can sustain before failure. In order, my idea is in order to obtain failure value, the increment of speed need to proceed until it's failed. So we know that the maximum force of landing gear acted. In addition, if the factor of safety are too high, the reduction of mass can be considered. In the meantime, can optimize the payload for UAV. Next paper, Dr. Abid Alihan, 2014. They're designing two models of landing gear to study the stress strain during static load applied. The parameters were obtained from the design with FEA CATIA and some assumption with manipulated variable of the force acting. Between the two models, the results were compared in terms of von Mises stress and von Mises strain, directional deformation, and maximum principal stress. Under Landsvis-Wexholm, India research paper about the arrangement of components of UAV, they state that because of the rigorous national and international rule and regulation that specify a wide range of requirements that must be met by such a system and all its integrated part in order to be approved by aviation. The different parts inside an airborne system in an UAV are designed to work as tightly coupled integrated system. This is to ensure that complete UAV system and all its integrated parts as such can be accurately verified, validated, and certified for aviation. Means that the design for UAV, the compartment must be follow the regulation that have been developed by the aviation. So, in order to design, the regulation must be considered. The problem statement, as I mentioned before, because the current design for fixed-wing UAV in Flight Technology Test Center UITM has traditional structuring landing gear design and integrated system. For the integrated system, it is for the landing gear, it is fixedly pinned with the mid-fuselage without having any mechanical system, which is unreliable in order to take off or landing, as theoretically the whole body of UAV will have less stability. For integrated system, for current design have some issue in terms of arrangement of the component for the current design of UAV and limitation of range and endurance based on the capacity of battery which it can carry. That's why we put the charging supply in the compartment. From my objective, provide a flexible, simple, and management arrangement of integrated system component for UAVs. The design landing gear and optimize in a way such that optimized structure for the landing gear can withstand deformation with some assumption of force acting on the landing gear. Scope and limitation. Static analysis on an landing gear with stress analysis by finite element method and calculation for static force acting on landing gear attached on the fuselage. In order to study the design analysis of landing gears, some parameters are required, such as analysis parameter. The project will be conducted through simulation on software for analysis and design. The prototype will be 3D printed to test and distinguish theoretical and experimental data. For integrated system, we'll study the design and sustainability of PLA when the system generates heat. Means that using the analysis for thermal resistance. For the limitation, it's required hands-on expertise and experience to handle. For a single machine, capital investment start in 800 Malaysia and can increase to as high as 1,000 ringgit or more. This is for the 3D print that we use to fabricate the product. We know that 3D print has a variation of type and purpose. So for a cheap 3D print, it will be cost as 800 ringgit Malaysia. Depends on how you want to how scale you want to print. 3D printers are limitless for mass customization, and they are slow when it comes to manufacturing many objects. This is fact because before this I had 3D print the previous design of UAV one part only, it takes 4 days to done. For methodology, as you can see here, the flowchart begin with design conceptualization and then CAD modeling and proceed with data analysis, record the result assessment, is it comply? If no, we design again. If yes, proceed with topology optimization. If it is not comply, we'll return to design conceptualization. A detailed computer-aided design is developed using modeling tool for further analysis. The dimension from existing design were acquired through different analytical models. The design was modified for few dimensions to reflect true geometry while remaining in the design parameters limit. This is the design conceptualization that I had done using CATIA software. As you can see, the top figure is the rear landing gear. At the first top part of the rear landing gear, that is to be fixed. This one, this is will attach at the UAV. And the two forks of the model are generated at an angle 139.7 degree with the fixed part. The part that attaches the wheel is generated vertically from the free end of the fork. This one is the fork of the called fork for the tire. For front landing gear, the concept is still same as the rear, but is included with blue rod, act as steering tie rod, so servo will attach to the blue rod for steering system. This one is the blue rod, so the rod from servo will attach at the middle of the blue rod, so it can steer the front landing gear. As you can see, this is the suspension system. Also, we'll add some suspension system at the fork. Okay, from the design, what we need to obtain before analysis is static load and geometry parameters for each landing gear. The static load will include the static load on front landing gear, ultimate static load on front landing gear, and static load per strut. The properties, we will find the volume and mass, and the length for x-axis, y-axis, and z-axis. The result that will be obtained after done the FEA, considering equivalent stress, elastic strain, deformation, and principal stress. In order to optimize, some other design will be designed to compare the best data considering the factor of safety. For optimization, factor of safety means to maintain its value weight optimization in a reasonably safe range. The comparison of the FEA data should achieve the best specification for the UAV parameters. Factor of safety will be considered in order to design and landing gear, thus the highest factor of safety will be the best design. And the last physical result will be taken from fabrication of the prototype for FIP2.